we have explain why CH3F is a polar molecule, even though the tetrahedral geometry often leads to nonpolar molecules. Okay, so for this we have CH3F polar question mark, and we have to explain why. So first, let's just draw out its little structure. So carbon will be in the middle, okay, and then we have 3 hydrogens and 1 fluorine. And now you may be thinking, oh yeah, this is obvious because of the electrons, but don't be misguided by the electrons here. The electrons do not always mean polarity. This whole molecule could actually just be sharing those 6 other electrons evenly throughout the molecule. What actually we have to do here is find the electronegativity differences, okay? So, if you go over to our periodic table and we start seeing the electronegativity difference, hydrogen has an electronegativity of 2.2. Carbon has an electronegativity of 2.5, 2.55 specifically. But fluorine, actually funny enough, the strongest electronegative molecule as we know of to this date, has 3.98. So let's look at the electronegativity difference for each bond. The carbon-hydrogen electronegativity difference is around 0.35 for each of those. In fact, around this range is what we actually consider to be a non-polar bond, okay? These 3 hydrogens and the carbon will be sharing the electrons evenly throughout as much as they can. What about the bond between carbon and fluorine though? 3.98, 2.55, that difference is really big, 1.43. So that means this fluorine here is going to have a lot more say compared to the carbon of who gets to keep the electrons, okay? The higher electronegative number is the one that the electrons will go to, and 1.43, because our typical cutoff for a nonpolar bond is around 0.4. This goes way beyond that. So this is actually known as a polar covalent bond. Okay? So that's one hint there, okay? So now that we have that, you can see here that it's quite uneven. This fluorine will be trying to hog all the electrons as much as it can, while the carbon hydrogens just kind of don't get a say, because fluorine is like, yes, I'm stronger than you all, this is mine, okay? So with that being said, this is how we can kind of say what's going on with our polarity. This is no longer an even sharing of electrons throughout. The fluorine will want to keep hold as much as it can of those valence electrons that we see here, okay? And that is why CH3F is polar. Even though, as I said, typically tetrahedral molecules are nonpolar. In fact, if I did CF on each one, this right here is also a nonpolar molecule, even though it has polar bonds. The reason being is because the fact that all the fluorines are trying to keep the electrons, and because they all have around the same amount of power, which is the electronegativity, they all cancel each other out. You're just like, okay, I respect your strength, I know you want to keep your electrons, so I can't really bother you. This right here is considered a non-polar molecule, and this is still tetrahedral molecular geometry, okay? Another example, as we know, is like methane. That one is a little bit more obvious because these are also just non-polar bonds as well, but same thing, they also cancel out. But as soon as you throw in something that no longer cancels out in terms of the electronegativity, even if you throw in for something like chlorine, this is also going to end up being a polar molecule. Although chlorine is not as strong as fluorine, it's still quite strong enough to where it can have a say in the electrons it's keeping, okay? So that's how we get that, okay? So with that being said, CH3F is polar because the electronegativity difference between carbon and fluoride or fluorine, and because there's no other part of it that would cancel out that electronegativity difference. Okay? So with that being said, let's see what our colleague said. We have a Lewis structure there. Fluorine, 3.98 electronegativity, and that's why it pulls the electrons towards it. Hence how we put this symbol here to show that that's where most of the negative charge would be concentrated. So now question number 13. We have it asking us today,